Inequalities. In order for us to solve a linear inequality or just solve inequalities, here's our process that we're going to do. We are going to treat it just like an equation, but if you multiply or divide by a negative on both sides, you want to flip the inequality. And so we're going to take all of our rules that we've been doing with solving for x's and everything we know to be true. We're still going to follow those situations. But now, if in that process of solving for x that you multiply or divide by a negative, we're going to flip the inequality. So what I want to do is let's work through some examples and see how that's going to pan out. Now, we are going to amp up these examples as we go, but if you need additional help or examples, just reach out. And so in this first one, what I want to do is solve for x. That's always been our goal. And so I would take and say, okay, well, here's both of my x's. I want to solve for x. So I'm first going to get all my x's over to one side. So I'm going to subtract 2x from both sides. That gives me 2x plus 7. Leave my inequality alone, minus 3. All I did was subtract. I did not multiply or divide by a negative. So I'm going to leave my inequality alone. Again, here's my x. I want to get it completely by itself, so I'm going to subtract 7 from both sides. Again, I am subtracting. I did not even multiply or divide, so that inequality stays the way it is, and then I get negative 10. And then, again, my goal is to get this x by itself, so in order to get that 2 off that x, I'm going to have to divide both sides by 2. So that gives me x is greater than or equal to negative 5. Now, even though my result is a negative, you'll notice, yes, I did divide right here, but it was by a positive number. So that inequality or that inequality sign maintained the direction it was facing. This says that x is greater than or equal to negative 5. Now, what the difference is in solving an equation versus an inequality is the fact that it gives us a range of numbers. It's giving you a lot of numbers that make this statement true. Let me show you what that looks like if we go to a number line. So at negative 5, I have something going on. It's equal to at negative 5, so I could color that in or use a bracket. And then I want all the numbers bigger than that. X is greater than or equal to negative 5. So that means I want all these numbers to the right. And so every answer in that shaded in value or from negative 5 to infinity would make my original problem true. So when we're solving these inequalities, just follow all the steps you know. But if you ever get to the point where you have multiply or divided both sides by a negative, then flip your inequality. Let's look at this next example here. It says negative 2x minus 1 is greater than or equal to 5. So again, our goal is to get this x by itself. So I'm going to add 1 to both sides. That gives me negative 2x is greater than or equal to 6. Again, my goal is to get this x alone, so I would divide both sides by negative 2. So it gives me x. Now, 6 divided by negative 2 is negative 3. Because right here, I divided both sides by a negative. That means I'm going to flip this inequality. So this is the case in point of the one difference between solving an equation and solving an inequality. So my answer would be x is less than or equal to negative 3. On a number line, these results would look like this. At negative 3, we're equal to. We want all the x's less than that, so that means we're going to be shading this area over here. Now, if we want to write this in interval notation, that means it would be negative 3 is our largest number. We're going off to negative infinity. Always parentheses on the infinity, but a squared off bracket on negative 3 because we are including it. Let's amp this up a little bit. Let's look at this next example. In this next example, we have everyone's favorite funness of fractions. And so what I want to do is I want to show you a little trick on how to handle this. What we're going to do is we are going to multiply by the LCD, by the least common divisor. And so we're going to say, okay, all my numbers are 4, 2, and 3. So that means what is the common denominator between 4, 2, and 3? And that would be 12. So I'm looking for a common denominator between all of them, and that would be the number 12. And so what I'm going to do is I'm going to multiply 12 times this entire situation. And multiplying through by 12 is going to eliminate all those fractions that really kind of freak us out. So I'm going to say 12 times negative 3/4. You can use your on-screen calculator to assist you with that. But that gives you negative 36 over 4, which gives me 9x, which is great. I don't have a fraction anymore. Then I'm going to multiply 12 times the negative 5 over 2, which gives me negative 60 over 2, or negative 30, plus I've got 12 times 2/3 x, which gives me 24 over 3, or 8x. And again, I would just use my on-screen calculator to assist me with that. So in this case, once I multiplied through by a really nice number, it really did its magic and got rid of all my fractions, amped up the numbers, but I'd rather take 9 and 30 and 8 and solve for x than those fractions. Just another way to solve this. You could work with the fractions though. And so now what I want to do is like what we did in the previous ones. I'm going to try and get all my x's together. And so I would say, okay, let's move this 8 over. So it gives me negative 8x. So I get negative 17x greater than or equal to negative 30, and divide by negative 17. Now this gives me x right here. Again, I divided both sides by a negative, so that's my one difference. I'm going to flip this inequality. Negative 30 over negative 17 reduces to just 30 over 17. Those negatives would reduce. Now, I'm not going to freak out that I got a fraction for an answer. That is possible, but I wanted to show you how this is really nice on how we can multiply in order to eliminate our fractions to make our processes a little bit easier. Now, how could I write these answers in interval notation? Let's see, that means 30 over 17 is going to be my largest. We're going to go off to negative infinity, and we are going to include it because of that equal sign. So x is less than or equal to 30 over 17. That means that I want all the numbers smaller than 30 over 17.